Hi everyone. Thanks for joining us today for this webinar, which is Managing Your Outdoor Assets with Barcodes and GPS. My name is Stephanie Giard and I'm the Marketing Director at Geospatial Experts. I am going to be the monitor for today's webinar. Moderator. Whoops. I have a few housekeeping issues to cover before we get started. We'll have a Q&A session at the end of the webinar and answer as many of your questions as time permits. You should have a vertical toolbar in the upper right-hand corner of your screen. If it's minimized, it should just show a red arrow, and you'll need to click on that arrow to see the available tools. There's a Q&A section in the toolbar where you can type in a question. So please feel free to type in questions at any time during the presentation. Your questions will be fed into the queue and answered during the Q&A session at the end of the webinar. I will be monitoring the Q&A throughout the entire webinar, so please use this tool to let us know if you're having any kind of technical difficulties during the webinar. All right, so effective identification and location of assets is critical to inventories, maintenance, and audits. Today we're here to demonstrate how to document and track your valuable assets using the latest technology in barcodes and GPS data collection devices. Once the data is collected, you can map your assets, create reports, or feed your information into a back-end database. Let's see here. There we go. Okay, so today we're going to cover all aspects of a complete asset identification system. That'll include photographs, it'll include descriptive attributes, barcodes, which is one of the most important descriptive attributes you can have, QA and QC of your data to make sure that you have high quality data going in so that you have good reports and analysis coming out. You can also You can map your locations and create reports and input your data into the database. So the folks that you have here with you today are going to be Camcode and Geospatial Experts. Camcode, founded in 1979, is a recognized worldwide leader for the design and manufacture of durable pre-printed barcode labels for asset tracking applications. Camcode stands for durability, compatibility, long life, accuracy, efficiency, and cost effectiveness. You also have Geospatial Experts, which was founded in 2001, so this is our 11th year in business and our 11th year as the leader in photo mapping software for professionals. Our systems are used worldwide. In the U.S., every federal agency, all state governments, and countless city and counties, as well as universities, use our software, as does much of the Fortune 1000. So that's a little bit of background on the two companies involved with the webinar today. And now I'll give you a little information about the speakers. First, we have Jeff Gibson, who is the Senior Sales Engineer from Camcode. And we'll also have John Clark, who is the Director of Business Development from Geospatial Experts. During the Q&A session, Rick Bobbitt, President and Head of Development for Geospatial Experts, will be joining to help answer your questions. So with the click of a mouse here, I am going to hand the presentation over to Jeff. All right, there we go.
Get focus back.
All right, here we go.
Thanks very much, Stephanie.
Show my screen.
And let me just get the change here. All right, let me just get caught up real quick. All right, thanks very much for joining us, everybody. I'm going to go through just a few topics here. One is AIDC and barcode basics, just so you understand the basics of a barcoding and data collection solution. The utilization and benefits of asset identification, and a little bit on selecting the proper labels for your asset and environment. AIDC refers to automatic identification and data collection. It's the method of automatically identifying objects, meaning using technology to input a specific serial number or identifier rather than writing something down or picking from a list. We then collect data about that specific asset and enter the data directly into a computer. So basically with AIDC, you're not doing any writing, no more data transcription. You're simply scanning a barcode to identify a specific asset, then entering the attributes and data about that asset directly into a computer system so that there's no transcription in the middle. The increased speed and accuracy of AIDC is where you get your bang for the buck, so to speak. First of all, it eliminates errors associated with manual documentation. How many times do you have something where somebody writes something down, someone else has to interpret it, and then type it into a system? Not only is the process redundant and a waste of money, it leads to frequent errors. For assets that move, you have the ability to collect tracking data and know its current location. So if you want to know the movement of an asset through different locations, it gives you the ability to do that as well very simply, because you know what that asset is regardless of its location because it has a unique identifier or barcode label. It improves your inventory control because you know what you have and where you have it. It also leads to better utilization of information such as warranty management or anything associated with that asset, because you can quickly look up any corresponding information on that asset in the system. It improves the through-life visibility of because you can track its entire history, movement history, maintenance history, audit history, very simply by using a system like this. It reduces the failures associated with identification errors. What I mean by that is I've visited several facilities, everything from HVAC units on the roof to equipment in a plant where there's multiple pieces of equipment that are exactly the same, right next to each other, or very close proximity, and sometimes the right asset is not maintained or inspected because they simply get it wrong. Barcoding and AIDC eliminates those types of errors, and then obviously it eliminates those legibility and data transcription errors as well. So you're taking all of the writing and reading and typing out of the equation. The benefits of AIDC are, number one, reliability, simply because properly inspected and maintained equipment performs more reliably. For assets that move, you can collect the history, so maybe you know, hey, this asset was in a very humid climate, now we've moved it to Denver where it's dry and arid, it may perform differently. You have that entire history. Another important thing is liability protection. We have had more than one occasion where we have sold this type of system to someone after they've lost a lawsuit because someone was hurt by an asset that was not properly maintained, and also they couldn't show an inspection history of that asset, which doesn't help in those situations. So anytime you're looking at regulatory or safety compliance, having that type of information in a computer system is going to help you with liability protection. Next, it comes down to accountability. If you can effectively track your maintenance operations, what was done to what, it simply enables more staff accountability. And then last thing, which we're seeing a lot of, is traceability. Now, traceability is moving beyond assets. We're doing a lot of work now in food service because they actually have to track the train of ingredients as they go into products, and that's another thing that we can do with barcoding. So whether it's traceability of an asset, maintenance, warranty information, you can track everything associated with that asset from cradle to grave. So where these two come together is with a barcode label and a good data collection system to get the attributes that you want. Collecting GPS coordinates and a digital photograph and associating them to a labeled asset gives you that type of definitive asset identification and location that people are looking for. Having photographs takes a lot of the guesswork out of what shape is it in, what does it look like, what's its condition, because you actually have a photograph of the asset. If someone's going out to do maintenance or audits and there's several pieces of equipment, they can tell from the picture which one they're looking at. It also gives you the ability to more quickly capitalize on operational data. Typically with manual data collection and transcription, it can be days before anything you find out about that asset during an audit or inspection becomes available to the users. With an AIDC system, as soon as that project is uploaded to the computer, you have visibility of what went on in the field. Utilizing what we call UID, which is unique identification, and AIDC simply gives you the ability to do much more timely and accurate data into your system, both so that you can set up better predictive maintenance or simply improve safety and operations. So on the auto ID side, what we're talking about here is barcoding. Okay? Barcoding is the most simple, straightforward method of auto identification. There are other systems such as RFID, memory chips, and things like that. But for the basics of asset identification, typically what you use is a 1D or linear barcode, just like what you're used to seeing on products that you buy, or UPC codes. In this case, the barcode label is simply the license plate for the product. So by putting a unique license plate on it, you then store the information associated to that in a computer system. The other type of barcode now, which is probably a lot more common because they're used for QR codes and advertising purposes, are 2D barcodes or two-dimensional barcodes. You see those on every package you get from UPS or FedEx. What's different about a 2D barcode is it can store multiple fields of information. So for instance, in the UID initiative that's going on with the Department of Defense, what they put, the three fields that they put in their 2D barcodes are cage code, or the manufacturer, the part number, and serial number, so they have traceability of every item simply by scanning a barcode label. In order to find the right label for your asset, it goes through a requirements process just like many other things do. The first thing you want to look at is the environment. You know, what is the moisture? How much sun? How much direct sun? You know, chemicals. What do you wash them down with? What type of abuse are they going to take? And from there, you also want to go into determine what size of a label do we need. Now, typically the size of the label is determined by the scan range that you need and the number of characters in the barcode. So designing the perfect label for your asset is maybe, there's a little more to it than most people think, but when you work with someone who understands it and knows the business, it can be pretty simple. So you can see that this is a fairly wide barcode label at the bottom simply because there are about 20 characters in it. So the more characters, the wider the barcode has to be. The other thing you want to look at is after this barcode label is attached, okay, first of all, how are we going to attach it? Do we use mechanical attachment? Can we use adhesives? Do we use both so that we have the opportunity to either use adhesive or mechanical attachment? So that's another determination. And the last thing is what's going to happen to the label after it's applied. Is there a chance it's going to get painted? Is it on a meter where someone may paint the meter when they paint their house? Is it on an asset in the city where you're going to have graffiti issues? So we want to take a look at all those factors in determining the right label and what's going to work on your asset. What we do is we produce long life durable barcode labels. The idea is buy a label which lasts as long as an asset. If you have a 30-year life of your asset, buy a label that's going to last 30 years on your asset. You won't have to do any relabeling. The next thing is we get a lot of questions about how do we number them? Do we want to use smart numbering? In this case of this example with the boiler, this is a company that wanted not only the equipment number, but the description. So in this case, it's what's called intelligent labeling or numbering, where they're actually using the equipment number or asset number already in their CMMS or computer system. In order to do this, obviously, it's a little more complex in applying the label because you have to make sure that you apply the label to the correct asset. But the benefit of it is there's actually information specific to that asset on the label. Most frequently, the label is simply used as a license plate or unique identifier for that asset. And license plate is the metaphor that seems to work best because it's very similar to how it works with the police. If you get pulled over, they're looking at your license plate. Your name and phone number are not on your license plate. They simply enter that number into their computer and pull up all the associated information in the database. So the barcode label is simply a license plate identifier, and all the heavy lifting and information is handled on the database side. The process that we use to manufacture these durable labels is called metal photo, or photoanodized aluminum. What we're actually doing is coating anodized aluminum with silver oxide so it becomes like a giant sheet of black and white photo paper, and we're imaging them with light. So because of this imaging process, you wind up with a label which is silver aluminum and black aluminum, has extremely sharp graphics, excellent readability to the barcodes, and will last 30 years outdoors. We also have different treatments that we can do to the labels. You can get HXT, or extra high temperature labels, which will go up to 1200 degrees. We also have 3 different Teflon treatments available for labels, both either for resistance to chemicals, to make them easier to clean, or because they have paint shedding. You can see in this picture, someone's painted over a Teflon barcode label, and in about 5 seconds you can just take that paint right off with either a thumbnail or wipe it off with a cloth, because it's not going to stick to the Teflon. Well, that's about it for the barcode label side of it. Now, I've been in this industry for about 15 years, and most of my experience is working with maintenance and operations people, dealing with outdoor assets, transformers, utility poles, fire hydrants, street signs, things like that. And these are the questions that when I ask asset managers or maintenance managers, what do you want to know about your assets? What is the critical information that you need to know in order to properly maintain and inspect your assets? Well, obviously, number one is what is it, okay? And the easiest way to do that is to put a unique identifier or barcode label on it, associated in a database, so that anyone can scan that label and find out what it is. The next thing they want to know, of course, is where it is. Well, the best method for doing that is GPS or geolocating, and you want a system that makes it easy to be able to grab those GPS coordinates for your asset. Next is what condition is it in? And this is something that is handled by this solution in 2 different ways. Number one, you have a photograph of the asset so that you can visually see what condition it's in. And also, you have the ability to assign attributes to the asset and edit those attribute values. So you can have a series of drop-down lists that give you different choices of attribute values to determine the condition. You use these same attributes to put in the model number, the type, the size, the year, any of that information associated. So then it becomes, okay, now we know what we want and what we want to get out of this. How do we do it? Is there a simple and cost-effective way to do this? I want to be able to get this information using simple commercial off-the-shelf hardware and have users that can understand it quickly and go out in the field and get me this data and this information without a whole lot of user training or having to call tech support. So in my years, I have seen hundreds of different software solutions and worked with quite a few, and for the straightforward and simple act of being able to collect asset information, geolocations, and photographs, put them into a system where you can either very easily print reports or export to a database, and has the ability to do project-based systems, which I mean by that is you can say, today we're going to go look at all the fire hydrants, tomorrow we're going to do the playground equipment. You can set it up as different projects, so either different groups or departments can work on doing this data collection with very specific assets. So I have found the solution that you're going to see now from Geospatial to be about the best for this. What I like about it, beyond its basic usefulness, is that it uses simple commercially available hardware. You don't have to buy expensive handheld devices or computers to use in the field which aren't going to be used for anything else. People already have smartphones. You also want them to carry a $2,000 handheld which does nothing but data collection, when you can simply use their existing hardware, either smartphones or tablets, to do the data collection without any hardware costs or infrastructure costs. So hopefully this has got you interested enough that you'll take a really long look at the solution, and at this point I'm going to turn it over to John Clark, who will show you that information.
Thanks, Jack. Again, I'm John Clark. I'm with Geospatial Experts, and going to go through a bit about our systems here today. Want to reiterate what both Jeff and Stephanie have said is the barcode is oftentimes the key attribute and can facilitate appending and merging of new information about the asset with database and asset management systems on the back end. I'm going to start out with a picture here of, I'm trying to find the right slide, bear with me. There we go. Of what exactly we mean by attributes and attribute values. Captured attributes can significantly contribute to the quality and soundness of your decisions. The system that we'll demonstrate today captures and maps GPS coordinates, barcodes, and alphanumeric information about the object or the subject of the photograph. This is an example of a city street sign inventory. It shows a photo of a loading zone sign and both the attributes and the attribute values that have been collected to describe it. The first three attributes and their corresponding values are barcode, and we have the barcode number there, sign type, which is loading zone, and action required, which is replace. Our actionable information is simply replace the faded loading zone sign. Your end users get the information they need for asset management and decision making from a variety of systems and tools that use output created by GPS PhotoLink, our desktop processing software. Because our collection and processing system can provide the kind of output to support most end users, it is important to think about how your information consumers will use the information collected about your assets. The most straightforward output is to watermark attribute values on the photographs. Here, the Army Corps of Engineers has collected information as part of the federal mandated real property audit, in this case a picnic shelter at Bear Creek Recreation District. Attributes are in the yellow column and their corresponding attribute values are in the white column. Printed and map and web-based reports meet another end-user need. Here, a street audit report shows a photo of each sign at the top of the page. In the middle of the page, it locates the sign on both a street map and a satellite map, and at the bottom of the page, it has a table showing both attributes and the attribute values. Our systems also provide input for digital mapping applications such as Google Earth and Esri's ArcGIS. With ArcGIS, GPS PhotoLink, our desktop processing system, is actually integrated into the ArcMap menu. For input into your back-end systems such as relational databases, asset management, or even spreadsheets, you can select either a Microsoft Access 2000 database or comma-separated value output. Our professional services team can provide help with appending and integrating newly collected data with information in your back-end systems. Professional services can also help with custom solutions such as this internal website that provides views of the signs inventoried, their map locations, and their attributes, all viewed through the web. A similar example is this public-facing website. Accomack County, Virginia uses our systems to provide web-based hurricane damage information for its citizens. So its citizens can actually look up on the web to see if maybe their property or a friend's property has been damaged by the latest hurricane. Just to recap, our GPS PhotoLink and GeoJot system supports most end-user reporting and presentation needs, and everything from watermarked photos through database and spatial database systems. We'll be demonstrating field collection systems and our desktop systems next. So the two systems we're going to look at are smartphone and smart tablet-based systems and camera. And both systems capture GPS information and photographs and attributes and barcodes. First, the Ricoh camera, the G700, is a specially designed GPS camera that captures high-resolution photographs, barcodes, GPS locations, compass direction, and up to 20 descriptive attributes for any photo. It is also ruggedized to military specifications, being water, dust, chemical, and shock resistant. We'll show you the camera in a second, but this is a shot of the back of the camera menu. The field user selects attributes by choosing them from pick list menus that Jeff talked about on the large screen on the camera back. The pick list menus are created by the user to support each kind of project that photos, GPS, and attribute information is needed for. All GPS, compass, barcode, and attribute information collected via the camera is permanently encoded into the photo JPEG file. The GeoJot application for smartphones and tablets enables photos and attributes to be collected in the field and transferred automatically using the cloud to designated office or field computers. The photos are imported into our GPS PhotoLink processing system for the creation of the user-selected output that we've talked about. Next, we're going to demonstrate the collection and processing systems. And I want to point out a next step after today's webinar is to schedule a project-specific webinar for your own organization. So as you watch the demonstrations today, please think about how your organization might use these systems. And then please contact us, because we'll happily set up a short webinar that we can talk specifically about your project with your team. So I'm going to change focus here, and we're actually going to look at the GeoJot application. And we're going to be doing that through a camera. And this is an iPad with the GeoJot application running. And I want to just go through a few things about the application. This will run on both Windows and Android smartphones and tablets. And so what you're looking at here is the home page, and it's divided into three sections. The first is Manage Attribute Lists, and we'll delve into that in a second. The middle section is the camera section, camera and camera roll, and the bottom section is the Settings and Help area. So to begin with, let's talk about attribute lists. And we've shown you what attributes and attribute values are. This is a list of the project type attributes that I have on this specific computer. To point out a few things, for instance, we can collect information about graffiti An example we've used with the Forest Service is an example for forest fire investigation. Today, what we're going to use is a list called Asset Inventory and Audit, and I've checked over here on the left-hand side, making that my default list. When I choose that, I get a list of the attributes, and for each of these attributes, now I want to collect information for my photograph. And so, for instance, and this is where I build my attributes. These are for asset type. These are the kinds of attribute values I can have. Yield for the sign, for instance, yield, slow, stop, school zone, etc. Just a second here. So I'm going to go back to the list. If I want to talk about action required, I can have things like no action, paint touch-up, replace sign, replace pole, unbend, and then choose any of those to attribute my photograph with. If I want to choose another kind of action required, I can add to the list simply by touching the plus sign. So if for some reason I need to sand the sign, I can actually add that to the list, touch done, and now that's added to my selection of attribute values that I can use. So these are where you, the user, can change the attributes that you collect and the attributes that you can select from a pick list. And this is all editable by you. If I want to talk about the condition of the sign, and what I'm really on today is a missing sign project, I can actually grab that and move it up to the top where it's going to be easier for me to use. And when I'm done, I simply touch done, and I've edited my attribute list. If you want to build a completely new attribute list, and maybe it would be for a pole audit, I simply create a new attribute list, and I have now pole audit. I can choose that, and now I can start adding attribute values to that list. So this is all very flexible and fits any kind of project very easily. What I'm going to do now, though, is let's go back and actually go to the camera, and this is what you'll see when you're out in the field and taking photos of your assets. So I'm about ready to take a picture of a sign. Some things I want you to notice. One is it tells me up here which attribute list I'm using. It tells me my latitude and longitude, my compass direction, and my GPS accuracy. If I don't want some of those showing, say GPS accuracy, I can turn it off, and now that is no longer showing. Importantly, for some asset audits, is I can lock my GPS coordinates, and the information turns to yellow. I can walk up to, for instance, this sign and lock my coordinates, and then if I want to, I can then back away and take various pictures of that sign from any distance and angle, but those photographs will still have the same GPS coordinates. So I'm going to take a picture, and I'm going to say what kind of asset is it. And I didn't even notice. What kind of sign was it?
Information.
Information sign. There we go. So I'm labeling it information. Its condition, let's say, is broken pole. And is it up to code? Yes. So when I'm done collecting attribute information, I touch done. This information is now written into the JPEG of the photograph. If I go now home and go to the camera roll, I can see the last photo I took. I can see the attributes if I switch focus here to asset type information, condition broken pole, etc. I can also within GeoJot see where it is on the map. Of course, we're doing this right out of our offices, and so it's locating us right in our own office. I can also see the photo that I just took from the camera roll. I can send it if I want to. Right now I have it set up that every photo I take is automatically being sent to a designated computer and a designated directory through the cloud. So that's happening automatic. I could also individually email this photo and the attribute information to, for instance, myself. So we have a nice way of transmitting the information among users. And I might point out also, coming back to the attribute lists, if I wanted to share this attribute list with my team, I can also email the attribute list to all my team members, so we're all collecting consistent data. So with that, I'm going to switch the focus from GeoJot, and I guess one last thing before I do that. I'm not going to demonstrate it here because it's a little hard to see on camera, but the GeoJot application for Android, whether you're using a smartphone or a tablet, will collect your barcodes. So you just scan it through the lens and it will populate the barcode attribute field. In this case, it's the first attribute I collect in a photograph here. So with that, I'm going to switch and demonstrate the other collection device, and that is the Ricoh G700 camera. And we'll try to get this in focus so you can actually see the back of the camera menu. There we go. If you can see here, the second line down is sign type. So here's my list. I can change the sign type. I know it's a little hard to see, but I'm collecting information about a duck crossing sign, so I'm going to choose that. The top attribute is barcode. So now what I'm going to do is simply scan a barcode. So with the camera, I get a reading of the barcode. And I just need to get it all in the camera field here. And the barcode itself is scanned into the first field in the menu on the back of the camera for the Ricoh camera. So with either GeoJot or the Ricoh, we can collect both the attributes that we've talked about and barcode information. So now I'm going to switch focus to what we do with the information once it's been collected and either transmitted via cloud or email or USB cable or removable SD disk back to the place where GPS PhotoLink can access the files, then we will build a project around the signs and inventory, and I've already done that. So here's our project manager that Jeff had talked about, and the project that I have opened is signs and asset inventory. And you process the photos first by going through a 7-step wizard, and the first step is to simply import the photos. To import the photos, you either navigate to the directory that they're in or drag and drop them in, and you import them into your project, which I've already done, and this project is, of course, a sign inventory project, so these are the photos that have been imported for the sign. All of my photos, because they've been taken with and attributed with either a Ricoh camera or a GeoJot smartphone, have attributes. So I'm going to jump to the third step, which is the attribute editor. The attribute editor has 3 sections. The first section is the photo section, so we can see what photo we are focused on. The second section is the alphanumeric attributes, and the third section is the map section. So I'm going to switch photos here. You'll notice that any photo that I'm focused on turns blue in the photo section. It also turns blue in the on the map. So I'm focused on the 15-minute loading zone sign. I'm going to focus in a little bit by zooming in, and that shows me where the loading zone sign is. Now, I'm going to go back over to the attribute editor and point out this is where you quality control, you edit any of the information that you want your end users to use. Any information here that is in blue is editable, and I can edit the information for one photo, for selected photos, or for all the photos. So be aware now there's a number of different sections of information, attribute information. One is the photo section. The next section is the GPS section showing latitude and longitude. Well, to show you what we can do, I happen to know, because I've just come in off the project, that faded loading zone sign is a little bit off. Both of our collection devices are accurate to 5 meters or 15 feet. And so I know this one really should be scooted a little bit that way. What's going to happen is my latitude and longitude are actually going to change, and I've moved the sign to where on the map to where it actually belongs. So again, everything in blue is editable. I could have changed it over here by just typing in rather than moving the icon. If I wanted thumbnails rather than icons, I can, for orientation purposes, I can show my my project using thumbnails. I can also zoom out to show all the photos in my project. So in this park district, here are all the sign photos, and right now I'm using icons, and I can even use big icon photos, and this helps me get oriented. Typically when I'm using it, I like to show thumbnails, so I'm going to toggle back to that. The other kind of attributes that we've talked about that are very, very powerful are your alphanumeric user controllable attributes. So in this case, for the loading zone sign, we have the first attribute is a barcode. The second is the sign type, the material, what condition, etc. So all of this information now has been collected in the field, although if I want for some reason to change it, so we just realized that the code is in compliance actually through 2013 for all these signs. I can change them one by one or selectively. So all of this is editable by the user. The idea is to get all of your information ready for either the report, the database system that you're going to use and your end users are going to use. The next section is the photo editor, and that's the same idea. We want to get our information ready for the end user. So for instance, if all we're really interested in with this sign is not the no parking but the senior center, I can crop in on that and zoom in. I can change the color, improve the color, the contrast. I can annotate with alphanumeric information, but the idea is either data or alphanumeric attributes is to get them ready for the end user. I might point out here also, we can undo edits that we've done to either the photograph or the data, and that's important. We work with this system with copies of the photographs and the data embedded and collected originally, so that's always available if you have to go back to original information. The next thing is we can watermark the photographs. So here's an example of the sign with watermarks, and in this case outside of the photograph. And we select our watermarks by choosing them from our attributes. So if I say, well, I don't really need the barcode in the watermark, I unclicked it, it subtracted off my watermarks here. If I say I really don't need the, whether this is in code compliance or not in my watermark, I can unclick that here or over here. You control the column and the row of the watermarks using these controls here. So we have left, center, right for columns. We have 6 rows at the top and 6 rows at the bottom for the watermarks. I can move the watermarks inside or outside of the photo. Here I've moved them inside. I can choose the color, size of the watermarks, so you have full control over that also. The second to the last step is the shared output settings, and here you control information about how you want your report to look, size of photos, information you want on your report, whether you want to add logos to your photos. If it's a client or a customer, you may want to add yours and their logos, and you just browse to where those are. You choose, for reports, you choose what the source of your maps. So do you want to use Google Maps? Do you want to use ArcGIS maps or USGS maps? You also can choose how far from Earth you want your map to show. So do you want it to be very close to Earth, or do you want it to be a long-range map? You can also choose custom maps. So if you have your own maps, you can select those also. You choose here what you want to show in your attribute table, and this is going to be important, particularly if you're appending databases. So generally speaking, here what you'll do is choose the attributes you want in your attribute table by clicking them, same convention, and then arranging them. So if I take memo 5, but I want to move it up, and usually I'll do this so it aligns with the columns in my database. So it's easier to bring this information into a relational database. Lastly, and very powerfully, you can choose to rename your photos. So if we say, gee, the barcode is the unique identifying feature of this photo, I want that as part of the name. In fact, I don't want it the last thing. I want the barcode to be the first thing. So I'm going to move it up. And actually, I'll move it all the way to the top. So I see a preview of my renamed JPEG, and the barcode is part of the name. That's the first thing. When you're done with all of that, you then select what kind of output you want. So, for instance, do you want to create Adobe report files? So you can click any or all of the output settings, and each one has a certain amount of user control. You can control maps, overview maps, and things like that. For ArcGIS Esri systems, we have shapefiles and geodatabases, personal, file, and enterprise, including the option to do blob type databases, geodatabases that'll include the photographs right into the geodatabase, so you don't have to worry about broken links. Same with Google Earth KML, KMZ files, Universal Digital Map Exchange files, Microsoft database files if you're going to be appending or integrating with a relational database, and of course comma-separated value files. So when we're done with all of that, you're ready to create the output, which I've already done. And if I pull down my project, I can see, in this case, I've created a shapefile. I've created a file for watermarked photos. And if I thought, gee, all my settings for my reports and everything were just exactly what I want, I can make this a template. So now this project becomes a template for future projects. With that, I'm going to conclude, and we'll break it open for questions and answers. And I think we have a list here, so I'll open up the list and see if we can help answer your questions.
Okay, this is Rick Bobbitt again. One of the first questions we had was about data validation in the memo lists or the attribute lists, and right now we don't. The only data validation we have is when you select an item from the drop-down list, and that item will go in to the attribute. But we don't have any kind of cross-referencing between attributes or any kind of data validation like that. So again, please type your questions into the box, and we'll try to get to them as quickly as we can. So then the next question is about what location is captured. Normally, when you take a photo with a GPS camera, it's the location of where you're standing, not the location of the object. However, with GeoJot and the Ricoh camera, we have a lock GPS functionality where you can walk up to the object, lock the GPS to that position, then walk back 20, 30 feet and take a photo. That way, the actual point you're collecting is the object or sign, but you're taking a picture that could be 20 or 30 feet away from that. Then the next question is, explain how GeoJot scans the barcodes. And I know John showed the Ricoh camera scanning barcodes. Do we want to try to do this? Well, in GeoJot, how it is when you, instead of the data entry screen, there's a button that brings up basically a camera view, and you hold that up to the barcode, and it scans the 2D or 1D barcodes and puts the value back into the data entry field. So it works pretty simple.
It stores it as an attribute.
And it stores it as an attribute, that's right, inside of the photo. Somebody asked how many images can you link to GPS location? Almost unlimited, basically. It's based on your size of your data card on your camera or your memory on your phone if you're using GeoJot. So you can do thousands and thousands and thousands of these with no problem. Again, if you have any other questions, just type it into the box. We're getting some in here. I don't know if one of you guys want to take this question about how they might name the photo or name the signs.
If you have thousands of signs, a lot of them will be the same type. A lot of what we do is workflow related. So I think, you know, when we've showed if you were bringing in old photos of signs, and you could say, I want all my information signs in one group, all my warning signs in another group. You could use one of the attributes fields to have those types of signs, and then use that attribute field as part of your name.
As far as the actual naming conventions, Esri has provided a data dictionary that is free. If you email us, we'd be glad to provide that link. And it makes it very simple to go into those lists and they have everything all spelled out, basically all the different types of attributes that would be associated to all different types of assets.
Right. And someone clarified their data validation question, meaning if you selected one field as a broken poll, then you wouldn't be able to select meets code in another field. And right now we do not have that kind of data validation. It's just simple text right now. But we're looking into doing some more data validation and cross-referencing rules on those attributes for the future. Someone asked about creating shapefiles in Esri for use in the Esri software, and that's what the GPS photo link here does. So in the project, when you click select shapefile here, then when you click finish, it will actually create that shapefile. And then in the output, when you see the output of a shapefile, so this is all of our outputs, you can just click on a little eyeball here and it'll bring up that shapefile into ArcGIS. You can create shapefiles or geodatabases as well. I'll take that one, John.
There is enterprise licensing, and I'd be happy to talk with anyone about that offline with different packages to meet different situations. So just let you know, we have for instance, a nice starter package. We call it GeoJot Enterprise, and it does come with 30 GeoJot licenses and an enterprise license for PhotoLink software. So be happy to give you more information about what's involved in an enterprise package and the pricing.
And then someone else again asked about the different locations, whether the camera location or user location. And with the Ricoh camera, you can connect up a laser rangefinder. And with that laser rangefinder connected to the Ricoh camera, you can stand off by a couple hundred feet and shoot the object with the laser, and then it will store that distance and direction inside the camera. And then we can compute the actual location of the object you're taking a picture of. And we're planning on trying to incorporate that into GeoJot for Android as well.
And I guess also, if a pole isn't accessible, you can't get up to it to get your location, you would have to take the picture from as close as you could get, and when you go back into GPS photo link, you would have to move it, because you do have the ability to manually move them, and you can zoom right in on that map, look at it in terrain view, and get a very clear idea of where it's supposed to go.
Or even if you don't have a laser rangefinder, you can have an attribute that's distance with a drop-down list of 25, 50, 75 feet, then you can at least get an approximate distance to where that object was.
I think we've answered most of the questions. Some of them are kind of repeating themselves from different people. So I want to reiterate here, we could not go into depth. We'd like to set these up. Jeff and I will do this jointly to talk with you about your own projects. So please contact us. I'll put our contact information back up on the screen. To arrange a short webinar with your group based on your project, it's pretty easy for us to kind of get a dummy up a project that kind of fits what you might have in mind and then talk you through it. So please contact us. We'll be happy to arrange that at your convenience. And with that, I'd like to thank everyone for coming today. I hope this was a good introduction to both barcoding and asset management using GPS attribute information. So again, thank you. Appreciate your attention. And goodbye now.
Thank you.